Today, there is a huge demand for fuel because of the increasing population. Biomass is a renewable source and is available very easily. It is the third among the primary energy sources after coal and oil. Biomass. Biomass is a plant or animal material used for energy production or as raw substance in various industrial processes for a range of products. It can be purposely grown energy crops, wood or forest residues, or waste from food crops like wheat, straw, bagasse, horticulture waste, and also from waste from animal farming, or it can also be human waste from sewage plants. Gasification. Gasification is a technological process that can convert any carbon-based raw material such as coal into fuel gas. This is also known as synthesis gas or syngas. Gasification occurs in gasifier, which is generally a high temperature or pressure vessel where air and steam are directly contacted with the coal or other feed material and causing a series of chemical reactions to occur that convert the feed into a syngas and slag. Biomass gasification. Biomass gasification means incomplete combustion of biomass, resulting in production of combustible gases consisting of carbon monoxide, hydrogen, and traces of methane. This mixture is called producer gas. Producer gas can be used to run internal combustion engines. Both compression and spark ignitions can be used as substitute for furnace oil in direct heat applications and can be used to produce methanol in an economical way. It is an extremely attractive chemical which is useful both as fuel for heat engines as well as chemical feedstock for industries. This gas is a low heating value fuel with a calorific value between 1000 to 1200 kilocalorie per Newton meter cube. Main reaction or process which occur inside a biomass gasifier are drying, pyrolysis, oxidation, and reduction. Drying. Biomass fuel usually contain moisture. When it is heated to about 100 degrees Celsius, the moisture is converted into steam. Pyrolysis. Pyrolysis is the heating continuously without supplying any oxygen. As a result, the biomass is decomposed or separated into solids, liquids, and gases. Oxidation. Air is introduced into the gasifier after the decomposition process. The reaction is carbon plus oxygen to give carbon dioxide and heat. Reduction. Reactions for reductions are like carbon plus carbon dioxide to give carbon monoxide, carbon plus water to give carbon monoxide and hydrogen, carbon monoxide plus water to give carbon dioxide and hydrogen, carbon plus hydrogen to give methane. Now let's talk about types of gasifiers. There are generally four types of fixed bed gasifiers used in biomass gasification. They are updraft gasifier, downdraft gasifier, open-top gasifier, and closed-top gasifier. For the shortage of time, here we will talk only about updraft and downdraft gasifier. Updraft gasifier. In this, air is intake at the bottom and the gas leaves at the top. Near the grate at the bottom, the combustion reaction occur, which are followed by reduction reaction at higher up in the gasifier. In the upper part of the gasifier, heating and pyrolysis of the feedstock occur. As a result of heat transfer by forced convection and radiation from the lower zones, the tars and volatile produced during this process will be carried in the gas stream. Acids are removed from the bottom of the gasifier. The major advantage of this type of gasifier is its simplicity and high charcoal burnout and internal heat exchange, leading to a low gas exit temperature and high equipment efficiency. And this gasifier can be operated with many types of feedstocks like sawdust, cereal waste, etc. And the one major drawback is the oxygen leakage, which can be due to the channeling in the equipment, which create dangerous and explosive situations. So it is necessary to install automatic moving grates. Other problem is associated with the disposal of the tar containing condensates that result from the gas cleaning operations. But this can be solved if the gas is used for direct heat application, in which case tars are simply burnt. Now let's talk about downdraft gasifier. A solution to the problem of the tar entrainment in the gas stream has been found by designing a co-current or downdraft gasifier, in which primary gasification air is introduced at or above the oxidation zone in the gasifier. The producer gas is removed at the bottom of the apparatus so that the fuel and gas move in the same direction. On their way down, the acid and tarry distillation products from the fuel must pass through a glowing bed of charcoal and therefore are converted into permanent gases like hydrogen, carbon dioxide, carbon monoxide, and methane. The main advantage of downdraft gasifier lies in the possibility of producing a tar-free gas from suitable for engine applications. Because of the lower level of organic components in the condensate, downdraft gasifier suffer less from environmental objections than updraft gasifier. A major drawback of the downdraft equipment lies in its inability to operate on a number of unprocessed fuels. A low-density material gives rise to flow problem and excessive pressure drop, and the solid fuel must be pelletized or briquetted before use. Downdraft gasifier also suffer from the problem associated with high S content to a larger extent than updraft gasifier. Now let's talk about biogas. Biogas is the mixture of gases produced by the breakdown of organic matter in the absence of oxygen. It primarily consisting of methane and carbon dioxide. Biogas can be produced from raw materials such as agricultural waste, manure, municipal waste, plant material, sea waste, green waste, or food waste. Biogas is a renewable source of energy. In India, it is also known as gobar gas. Biogas plants. Biogas is produced by anaerobic digestions with methanogen or anaerobic organisms, which digest material inside a closed system, or fermentation of biodegradable materials. This closed system is called an anaerobic digester or biodigester or bioreactor. Working of biogas digester. In biogas digester, microorganisms transform biomass waste into biogas. Tanks should be properly sealed with no oxygen and warm temperature. Produced biogas is cleaned using biogas scrubber and H2S is removed to use it efficiently. This flow diagram shows working of biogas plant. These are the raw material which are fed into the anaerobic digester to produce biogas, which is used to produce heat and electricity, or it can be used to produce biomethane, which is used as a fuel or gas, and the digestate is used as fertilizer, soil amendment, and livestock bedding. Advantages of uses of biogas for cooking and heating. Biogas burns very cleanly and produces fewer pollutants during cooking than any other fuel except electricity. Biogas provides instant heat upon ignition. No preheating or waiting time is required. Most biogas burners are able to regulate the flow rate to turn down fire power from high heat to small low heat for simmering. Biogas can be used for lighting as well. The byproduct from the digester can be used as fertilizer. Biogas is a renewable fuel that is carbon negative. Unless there are leakage in the system, burning biogas in a cook stove releases less greenhouse gas than if the dung was left on the ground to decompose naturally. Now let's look at some disadvantages of biogas. High investment cost for digester, tubes, gas stove and ports. Biogas can increase the workload of women, especially in India, as it is often made their task to run the digester. It is quite a physical burden to move all the biomass feedstock and water to feed the digester. Also, the slurry must be removed and taken to the field at regular intervals. It is not viable for elderly or sick people to run a biogas plant on their own if they don't have labor to assist them in the maintenance of the digester. Cooking with biogas requires a change of cooking habits, which might prevent the adoptions. Biogas is difficult to store and to transport to the other consumers. India and biogas. It can be used in home for cooking and heating, but it is not successful in India because in village it is found that burning cattle dung cake is more efficient than producing biogas. Cow dung gives energy of about 4000 kilocalorie, but biogas gives energy to about 200 kilocalorie. Also, people in rural areas can sell their cow dungs, but cannot sell their biogas. It also requires about 30 liters of water every day, and for the places where there is scarcity of water, it become a mess. Once India was ahead in producing the biogas, but now China is ahead of India. Thank you.